Welcome to this new activity, which is about computing areas between curves. So here I will give you two functions and an interval, and you have to compute the area bounded by the two curves of f of x and g of x on the given interval. Let's start with the first one. So the strategy is to make it in steps, and the first step is to define a new function h of x, which is the difference between the two functions. Of course, you can set it as f of x minus g of x or g of x minus f of x. It doesn't matter. So you will consider this new function, for example, f of x minus g of x, and you write its expression, which is x squared minus 1 minus 3, so x squared minus 4. Second step is to find the sign of this function h of x on the given interval, which is 0, 2 in this case. And using continuity, we can list the points of discontinuity and the points where the function is equal to 0 on the given interval and use test points, okay? But here, the function is x squared minus 4. It's a regular function. There is no points of discontinuity. We're going to solve h of x equals 0. And of course, h of x equals 0 at x equals plus or negative 2 in our case, okay? Then you draw your interval, which is 0, 2 in this case. And you put the solutions of h of x equals 0 inside this interval. For the first one, which is negative 2, it's outside our interval, so we don't care about it. And we take the second one, which is 2, and the 2 here is the limit of our interval. Of course, we're going to take a test point to find the sign of h of x. So we will take the point 1, and we compute h of 1. H of 1 in this case is equal to 1 squared minus 4, which is minus 3, which is negative. So we can say that our function is negative on the interval 0, 2. And the third step is about computing the area. So we're going to compute our area by setting the definite integral between 0. We have a single interval and the sign of h is negative. So it's the integral between 0 and 2 of minus h of x, since h of x is negative. So of minus h of x dx. And it's equal to the integral between 0 and 2 of minus h of x, which is 4 minus x squared dx. Now, it's easy. You have to compute this, which is equal to 4x minus x cubed over 3, taken between 0 and 2. So it's equal, if you evaluate this quantity at 2, you will find 8 minus 8 over 3. And the value of this quantity at 0 is 0. So the final result will be 16 over 3. Next one. The two functions are x squared minus 4x plus 4 and 10 minus x squared, and the interval is 2, 4. So first step, define h of x, which is f of x minus g of x. So it's x squared minus 4x plus 4 minus, protect your function by brackets, so 10 minus x squared. Okay, so it's equal to 2x squared. If you simplify this expression, you will get 2x squared minus 4x minus 6. Pay attention to signs here. Okay, now second step, sign of h of x. So let's solve. Again, it's a regular function, no points of discontinuity. So the only points where the function may change sign are the points where h of x equals 0. And you solve the second degree equation, you will get two solutions, which are x equals negative 1 or x equals 3. Okay? Now, you set your interval. The interval is 2, 4. The minus 1 is outside, so we don't take care about it. and we consider only the 3, and we put it here. And we take test points on the two intervals 2, 3, and 3, 4. Of course, you can take any test point, okay? You can compute, for example, h of 2.5, h of 3.5. I will not put the details of the computation, but if you evaluate this function at 2.5 and 3.5, you will find a negative result here and a positive result here, okay? Now, how to compute your area? You just write that the area is equal. And here, you have to split your integral to two sub-intervals, or you can split your integral to two integrals, which are the integral between 2 and 3, and between 3 and 4. Between 2 and 3, the h is negative, so we have to consider minus h of x dx. And for the second interval, which is 3, 4, h of x is positive, so we're going to consider h of x dx, and we have to write our two integrals or compute them separately if you want, okay? So it's equal to the integral between 2 and 3. Remember that h of x is equal to 2x squared minus 4x minus 6. So if you consider minus h of x, you're going to invert the signs here. So you will get the integral of minus 2x squared plus 4x plus 6 dx. And for the second integral, you will get the integral between 3 and 4 of h of x, which is 2x squared minus 4x minus 6 dx. Of course, the computation of these two integrals is easy since we have just polynomial functions. So we're going to write the result, which is minus 2x cubed over 3 plus 4x squared over 2, or simply 2x squared plus 6x taken between 2 and 3 plus the antiderivative here, which is 2x cubed over 3 minus 2x squared plus 6x taken between 3 and 4. Again, here I will not put the details of the computation, but to compute this, you have to evaluate this function at 3 first, minus the same function at 2, you will get a result, plus this function at 4, minus the same function at 3. The final result after computation is 8. Okay, check this result, please. Now, we'll move to the next one, which is the area between f of x equals x cubed and g of x equals square root of x between 0 and 1. Again, here we're going to define our h of x, which is x cubed minus square root of x. Okay. Second step, solve h of x equals 0, which means x cubed equals square root of x. Okay. Or x cubed minus square root of x equals 0. And the solutions of this equation are x equals 0 or x equals 1, which are our bounds here of our interval. So let's put our interval 0, 1. Okay. And of course, you can put the 0, the 1, there is nothing inside. So you just need a test point to get the sign of h of x on this interval. You can evaluate h of 0.5, for example, and you will find a negative result. H of 0.5 will be negative, so the h is negative on this interval, and the area will be simply equal to the integral between 0 and 1 of minus h of x, which means the integral between 0 and 1 of square root of x minus x cubed dx. And here you can use the power rule, so you can write it as the integral between 0 and 1 of x to the power of 1/2 minus x cubed dx, which is equal to x to the power of 3/2 over 3/2 minus x to the power of 4/4 taken between 0 and 1, okay? And the value of this function at 1 gives 1 to the power of 3/2, which is 1, over 3/2, so it's 2/3, minus 1 to the power of 4/4, which is 1/4. This is the value of the function at 1, minus, and the value of this function at 0 is obviously 0, okay? So minus 0. So you will get 2/3 minus 1/4, which is 5/12. Next one. And last one here. We have f of x equals exponential x and g of x equals exponential minus x. Again, here you set your function h of x equals exponential x minus exponential minus x. You solve h of x equals 0, which means exponential x equals exponential minus x. Of course, you can apply the ln here to get rid of this exponential, so you will get x equals minus x, okay? And the only solution here is 0, okay? So we have our interval, which is 0, 1. Okay, so the 0 goes here, so there is nothing inside. You just need a test point here. You can take whatever you want with any real between 0 and 1 and test exponential x minus exponential minus x, and you will find a positive result. So the h of x will be positive there, and we can compute our area. Which is the integral between 0 and 1 of h of x dx, which means the area of the integral between 0 and 1 of exponential x minus exponential minus x dx. So it's equal, the antiderivative of exponential x is exponential x, and the antiderivative of exponential minus x is minus exponential minus x between 0 and 1. So here it gives exponential x plus exponential minus x between 0 and 1. At 1 it gives e to the power of 1 plus e to the power of minus 1 minus, and the same function at 0 gives exponential 0, which is 1, plus exponential minus 0, or exponential 0 again, which is 1. So at the end, you're going to obtain the area equals to E plus 1 over E minus 2. We can check that it's a positive area. Just to check that your answer is not wrong, okay, you have to check that your area is positive. When computing area, check please that the result is positive. Thank you for your attention and see you in the next videos.